Welcome back to the basics. We're talking powers and exponents today. Problem of the day. We have some multiplication and division with those special rules involving negatives and zeros. So go ahead and give these a try. Remember, if they are the same sign, the answer is positive. If they are opposite signs, so one negative, one positive, the answer is negative. Go ahead and attempt the problem of the day, and when you're ready, you can unpause the video. Welcome back. To understand what a power is, just like multiplication replaced repeated addition, division replaced repeated subtraction, powers are used to replace repeated multiplication. It's the next step. Okay, an exponent. Now these are just some terms, just so we're talking the same language. An exponent represents the number of times that the base, and we'll talk about what these are in a second, the base is multiplied. So for example, 2 to the third. If we look, the big number at the bottom is our base. Let's skip down the notes a little bit for a second. The big number at the bottom is called the base. The little number up top is called our exponent. We're talking about the anatomy of what these are made up of. It's the exponent. So again, let's look at the example up top. 2 to the third power. Our base is telling us what is being multiplied. Our exponent tells us how many times it's being multiplied. So we have 2 being multiplied 1, 2, 3 times. The big mistake, we're not doing 2 times 3. 2 times 2 is 4, times 2 is 8. So 2 to the third power is actually 8. The big number is the base, and the smaller number is the exponent. We just talked about all this. So 2 is our base that's being multiplied by itself 3 times. 3 was the exponent. It tells us how many times we are multiplying the base. You can calculate this by using straight multiplication. Right? 2 times 2 is 4. 4 times 2 is 8. So my answer is 8. Let's try one together. We take our base and we multiply it however many times our exponent tells us to. Altogether, this is called a power, the base and the exponent. 4 times 4 is 16. 16 times 4 is 64. Exponents and powers are great things to do in your calculator because the numbers can get pretty big. On your own, try 1, 2, 3, and 4. Write it out as long multiplication, repeated multiplication, and then evaluate or calculate the answer. You may use a calculator. Go ahead and pause and come back when you're done. Welcome back. 3 squared. Our base is 3. Our exponent is 2. So we have 2 sets of 3. The answer should be 9. We have 5 to the third. So we have 5 as a base. We're multiplying it 3 times. 5 times 5 is 25. Times 5 is 125. A lot of people probably are looking at their paper and see 9 for number 3. We're not doing 3 times 3. We're doing 3 sets of 3. 3 times 3 times 3. 3 times 3 is 9. 9 times 3 is 27. Last but not least, we get 156 for number 4. Special cases, exponent or 0 as an exponent. Your answer is always 1. Okay? In class, we went through exactly why that's true. So to go through, it won't even let you do the you try. 3 to the 0 power, 1. 5 to the 0 power, 1. 9 to the 0 power, 1. So whenever your exponent is 0, your answer is 1. 8 squared, again, just seeing who's awake here, 64. Special case, when 1 is a base, the answer is always 1. We went through in class why this is true, but you don't really necessarily need to know why it's true, just simply that it's true. So 1 to any number, 8, 9, 10, a million, doesn't matter, is 1. All right. Special cases, when there are parentheses. Okay, so we're talking about negatives with parentheses. Negative bases. We're not talking about negative exponents in this class. Negative bases. We have two examples. We have negative 1 wrapped in parentheses to the 4th power, and negative 1 wrapped in parentheses to the 5th power. So my entire base is negative 1. Those parentheses tell me that the negative is included in the base. Well, let's look. Negative 1 times negative 1 is positive 1. Times negative is negative 1. Times negative is negative 1. There's positive 1. So we get positive 1 for negative 1 in parentheses to the 4th power. Negative 1 times negative 1 is positive. Times negative is negative. Times negative is positive. Times negative is negative. So negative 1 to the 5th power is negative 1. Now this goes back to our multiplication rules to a small degree. If there is an even exponent, now this is when you have a negative base in a parentheses. When there's an even exponent, the answer is positive. When you have an odd exponent, the answer is negative. You still have to do the actual multiplication, though. This is just a rule to check whether you're positive or negative. Well, let's first look. Negative 4 in parentheses to the 3rd. I know that because it's an odd exponent, my answer has to be negative. So no matter what, I know that my answer, little answer box over here, has to be negative. My base is 4. Once I know whether it's going to be positive or negative, I don't have to worry about negatives anymore. You could go through and do negative 4 times negative 4 is positive 16 times negative. If you know it's going to be negative, don't waste your time. Ignore the negative for a second. 4 times 4 is 16. Times 4 is 64. Let's try one more. Negative 2 in parentheses to the 4th power. That's an even exponent. So I know my answer is positive no matter what. 2 times 2 times 2 times 2. 2 times 2 is 4. Times 2 is 8. Times 2 is positive 16. On your own, give 1, 2, 3, and 4 a try. Welcome back. We're going to skip number 1 because we just did it if you're paying attention. Number 2, we have an even exponent, so my answer is positive. 5 times 5 is 25. We have an odd exponent, so my answer is going to be negative no matter what. Remember, it's 3 times itself 3 times. Or again, if you'd like to, your base is technically negative 3, so you can write the negatives each time. I'm just saving you a little bit of effort. Negative 3 times negative 3 is positive 9. Positive 9 times negative 3 is negative 27. We just proved our rule. Negative 3 in parentheses to the 0 power. Anything to the 0 power is 1. Now, if it's a negative without parentheses, the big difference is when you have parentheses around your negative, the negative is included in the base. So I'm multiplying a negative number times itself multiple times. When the negative is not in parentheses, like negative 2 to the 3rd or negative 2 to the 4th, these examples we have up here, no matter what, the answer is always negative. See how the negative just hangs out by itself out front? That's because I'm multiplying the 2's, not the negative 2's. So no matter what, the answer is negative. Here, negative 4 to the 3rd power. Well, that's 4 times 4 times 4. No matter what, my answer is going to become negative. That's what those parentheses mean. You don't have to show the parentheses every time. Again, these are rules to check whether you're positive or negative. 4 times 4 is 16, times 4 is 64. My answer needed to be negative. Negative 2 to the fourth power. Now we did negative 2 in parentheses to the fourth power up top. Now we're doing it without parentheses. Up top, when you had an even exponent, when the base has a negative in parentheses, if it's an even exponent, the answer is positive. Here, if you have no parentheses, our base is 2, and our answer is just going to be negative. 2 times 2 times 2 times 2 times 2. This is the calculation you're doing in your head. 2 times 2 is 4. Times 2 is 8. Times 2 is 16. I know my answer is negative no matter what, so I get negative 16. Those parentheses make a big difference. We went from positive 16 to negative 16 just because of the parentheses. Go ahead and give 1, 2, 3, and 4 a try. Welcome back. No matter what, we know that whenever 1 is our base, the answer is 1. So we get negative 1. The rest of the answers we get negative 25, negative 27, and any time, even if there's a negative involved, anytime your exponent is 0, the answer is 1. Here is your homework. Be very, very, very careful at noticing the difference. Some of these have parentheses when there's a negative. Some of them do not. They are very different. Read the instructions very carefully. Some tell you to make sure you rewrite each one as repeated multiplication. If the work is not there for 7 through 12, the answer will not count. 13 through 18, use any method you want, including calculator. All right, thanks for coming by, and I'll see you in class.